In August of 2021, President Joe Biden made a political blunder of historic proportions.
Mr. President!
This sucker's quick.
He held an electric vehicle summit at the White House and didn't invite Elon Musk or anyone from Tesla. Not long after that,
Hello, Detroit!
Biden went out of his way to credit GM with leading the electric vehicle revolution.
You electrified the entire automobile industry. I'm serious. You led, and it matters.
These moves did not sit well with Musk,
Come on up here, Elon.
and most certainly led him toward a very public and deep-pocketed embrace of Donald Trump. You remember.
Can I get in? Yeah. Wow.
The truth, of course, is that it was Tesla that reshaped the auto industry.
I love Tesla.
Tesla turned electric cars into a reality. GM, like all the other American automakers, was an EV laggard. Which is what brings us to this. For this is the Wallace Battery Cell Innovation Center on GM's campus in Warren, Michigan, just outside of Detroit. The scientists and engineers inside of this building would like to make the case that GM now takes electric vehicles seriously. Like, very seriously.
This is Godzilla.
And the GM representative tasked with delivering their message is this man.
My name's Andy Oury. I'm a battery engineer at General Motors.
Thank you.
A few years ago, Andy had something of a soul-searching moment.
I've got kids, and I wanted to make sure that the planet is better for my kids than it was for me, and I said, I've got to do something about getting to an all-electric future.
He decided he wanted to put his MIT brain toward combating climate change, and he wondered if GM actually felt the same way.
After working in batteries for about 10 years, I was trying to figure out, was this company really serious about electric vehicles? And I was like, you know what, I'm going to email the CEO. And I emailed the CEO and I said, you know, our mission statement, it could really relate more to the environment. And she said, hey, I've forwarded this to our communications team. Don't worry, we're working on something. And it was about a year later where I finally got to learn what they were working on. It was that 0-0-0 vision.
The 000 vision stands for zero crashes, zero emissions, and zero congestion. And it's around the zero emissions that Andy will argue GM has done more than you might have noticed.
I think we've been quietly building an electrification powerhouse right under everybody's noses. We've invested between the Wallace Battery Cell Innovation Center and the Battery Cell Development Center next door, close to $900 million in those facilities to make full-scale prototype cells at rate. It's under construction. You can see the gray walls there.
Yep. Okay.
So that's going to build about 100x more cells per week than this facility.
And this was new. This was 2023?
You got it.
Okay.
Then we've got investments in our Gigafactories for manufacturing the cells in Ohio and Tennessee. There still ends up being a really big gap between what we can do here and when you want to scale up to a full-size Gigafactory, like one of our Altium factories in Ohio or Tennessee. Those factories make about 300,000 cells per day.
Per day. Wow.
Okay?
There are some obvious signs of GM's electric vehicle investments. GM has 13 different EV vehicle models, ranging from small cars to trucks. My Brexmobile, for example, is massive and has an astonishing 500 miles of range. It's fun to drive and impressive. Andy, though, wanted to show me the work that goes on behind the scenes. And so, deep into GM's R&D labs we went.
We're surrounded right now by a bunch of blue test chambers. Each battery pack that we design will ultimately end up in this battery pack being tested.
Okay.
We can push it above and below what you can do on the surface of planet Earth for temperatures, and then humidity we can take from as dry as the desert to, you know, as wet as the rainforest.
Yeah.
We have battery packs big and small. This is the battery pack that you'll find in the Corvette E-Ray.
Okay.
So this is a hot and humid test chamber. You can imagine it living in Miami during the hottest, most wet week of the summertime.
Yeah. This looks like a very nice torture chamber.
This is a table where we can show you cell technology evolution over time. So the EV1 in the late 90s started off with lead acid batteries, had less than 100 miles of all-electric range, and then around the late 90s, early 2000s, nickel metal hydride started to be used in hybrids. This is what you would find in a Prius, and then you get into that first generation of lithium-ion cells in vehicles like the Chevrolet Volt. So back in 2008, we launched with, I think, 38 miles of electric range. And then this cell today, which is my new favorite cell, our LMR cell. My new favorite cell. We can use LMR in our trucks to get more than 400 miles of range. Along that path, we also dropped the cost of batteries by a factor of about 10, as measured in dollars per kilowatt hour.
Okay.
All right, come on in. Welcome to the Mega Shaker Room. We have 3 shaker table rooms in this facility. We've got medium, large, and mega. This is the mega. It's so big that we had to dig out the foundation of the building and pour a separate foundation so that the system wouldn't shake everything around it.
Do people make things bigger than this?
Like this is what you would get if you were testing small satellites. One of the things that's really exciting about having this facility is it lets us build full-size prototypes of battery cells. Most people can't do that. We can.
The story here is that GM is doing fundamental research on battery technology. It's starting at the elemental level and then going all the way up to the battery packs and the final vehicles. Does it have battery partners like LG and Samsung? Yes, it does, but GM is also doing a lot of the work itself. The current battery technology GM is most excited about is known as LMR, or lithium manganese rich batteries.
Our strategy right now has been to make electric vehicles more affordable. We announced in May the lithium manganese rich chemistry, which is a game changer chemistry for electric trucks because we can use it in a way that gets range of over 400 miles, meaning we can get really excellent range at an affordable price for those customers. In the early days, these particles that are inside the battery, we thought of them as being homogeneous from their shell to their core. State of the art today is no longer a homogeneous particle. You might have a cobalt-rich shell and a nickel-rich core storing lithium ion. So nickel, manganese, cobalt. Most expensive is the cobalt, next most expensive is the nickel, least most expensive is the manganese. So what's happened over the last 10 years, everybody's been driving the cobalt down and they've been driving the nickel up. And that's great because you get higher energy density, lower cost. So the thing to do with LMR is to switch again. Take the nickel down and take the manganese up.
The battery work GM does is impressive. And also, at times, oppressive.
Popping in here. Hi, I'm Ashley.
Nice to meet you.
Nice to meet you.
In this lab, I will show you this is a hot precipitation reactor, so which you can synthesize CAM material precursors, and we are able to, through the synthesis, to be able to achieve targeted performance.
How many slides are there?
Lab actually just starting it now.
This is the beginning of the
this is
journey.
beginning.
Okay.
So basically, we can put one electrode at the bottom and keep in a certain temperature environment test.
Okay. Okay.
Come with us, Lev. We're going to right across here.
Oh, we're going across.
He'll show you all the equipment.
This is 5 nanometers. This is the sample exchange chamber. This area, the temperature was 1024 degrees C.
Okay. You guys ready to go on to the next one?
So we're
I spent
making
2 days at GM.
coatings and particles.
Hi, I'm Ashley.
And was greeted by a cavalcade of brilliant scientists.
I'm Ashley. Nice to meet you. I'm Ashley. Nice to meet you. Where are we going, Bob?
It was like a science fair endurance test.
It's about 50 to 100 nanometers.
And I just go like this.
My crewmates found the whole affair quite amusing
Machine learning and artificial intelligence.
as I slipped into a battery chemistry fugue state.
A third electrode.
Point cell case here.
Cook them like you would a lasagna.
You can see the surface area.
Chemical vapor deposition.
Electron beam.
Electron beam.
0.5% humidity.
Runs through it at a certain rate.
One cell setup.
In-house made modeling algorithms.
Thank you so much. This is crazy. You guys are nuts.
I blame Joe Biden for this. At some point, GM decided to free me from my PowerPoint shackles. And, well, I ended up somewhere quite glorious. This is GM's Factory Zero, located right on the edge of Detroit.
We build the Hummer, the truck, and the SUV. We're also building a normal Silverado truck and a GMC truck, as well as a Cadillac Escalade EV.
That's Nick, and he was my guide throughout this robotic wonderland, where I got to see how GM builds its EVs.
We take these cells and the first thing we build them into are these mini stacks. and then we start stacking them into what we consider a soft stack. To this turntable that's spinning, the robot's picking a full soft stack right now. It's gonna take it to the compression units. The press is gonna compress it, and then we do a really intensive electrical test after that.
Okay.
So this one right here, it's welded. As you can see, you have all of the spiral welds. Some are more of a golden color.
Yeah, yeah.
And that's copper.
Okay.
The other ones are aluminum.
We're just like surrounded by moving battery packs.
Yeah, and these packs are on AGCs, automated guided vehicles or carts. So this is where they start loading these modules 2 at a time, and it's got their barcode information scanned so it knows exactly what it's putting in.
Yeah, that was cool. So it just put the first pack in.
First 2 at a time. It's going to continue loading them. Once these are loaded, we're going to actually tighten them all down. This is Godzilla.
This is Godzilla.
So this robot right here is the biggest robot Fanuc makes. It is a monster. This is where we are going to take the finished pack off the cart, as well as where we load an empty tray to the cart for the processing to begin. So it's the start and the end of our pack main line, all in one station.
And in a final victory for humankind, I got to drive an electric Hummer right off the line. Let's cut to these geese on GM's campus for a moment, as I think aloud. There are some brutal truths that undermine GM's vision. GM, for example, has just recorded a $7.1 billion loss tied to its underperforming battery factories and electric vehicle assembly lines. Sales have slumped in part because of Trump whacking EV rebates. In the big picture, though, Americans just aren't as into electric vehicles as much as GM and others hoped. GM still tells me it's in this for the long haul, and I'm here, by this water feature, believing them more than I would have before my 2-day reprogramming campaign. Even a cynic, I think, would be convinced there's real effort going on. As for Andy, well, he's a true believer, and he thinks all of this is part of a plan to bring every piece of EV production back to the US again.
We want to have North American battery manufacturing independence. We want to be resilient to the point that we can chart our own destiny from the mines and the materials, processing those materials, putting them into the cells, and then into vehicles.
I remain skeptical on a lot of that, but am now at least open to the possibility of being proven wrong.